Okay, thanks for joining PRMO question a day. We will have 60 good questions in next 2 months, and these questions are definitely important and will be little difficult compared to your routine questions because they are PRMO type of questions. Maybe they will be little more difficult than actual PRMO also. And there was a difficulty in understanding the first question itself. So I thought I will just explain you this solution, which will help you to understand this. So the question is given that equation x upon x plus 1 plus x plus 1 upon x plus is equal to 4x plus a upon x into x plus 1 has only one real root. Okay, so this only one real root is important condition, which is additional condition, which is given in this question, and find the real value of a. Okay, so in this solution I think this is correct. This is understood by everybody because if delta is equal to 0, then you have a repeat root. Repeat root means it is only one root available two times. So that is straightforward value of a by equating discriminant equal to 0. A becomes half. Now, when this type of question is given, we even if it is not stated, what is assumed is if this question is true, x is not equal to 0 and x is not equal to minus 1, because the moment x becomes 0 or x becomes minus 1, the question itself is not defined. Therefore, if somebody is asking this question, it means that domain of definition of x does not include 0 and minus 1. So these two x values are not available at all for evaluation. And therefore, delta greater than 0, when you end up having two distinct roots as far as theory of quadratic equation is concerned, this condition becomes important. Delta less than 0, I mean, we will not get any root because imaginary roots will be there, and we are supposed to figure out only real roots. So this will not produce any root, that is correct. Delta is equal to 0 has got one root, that is correct. But now delta is greater than 0. Instead of having two distinct roots, will there be a situation or a value of a for which you end up getting only one root? Yes, that is possible. So if one root is 0, then you can have another root x1. These two distinct roots eventually will be there because of delta greater than 0, but 0 cannot be a root because question itself becomes undefined. Therefore, you find out value of a for which you have distinct roots, that is delta is greater than 0, but one of the roots is 0. So if one of the roots is 0, that means you just substitute 0 in this equation. This is your quadratic equation and you want one of the roots to be 0. Then what is the value of a that you get? So if we put x is equal to 0, 0 here, we get a is equal to 1. So if we put a is equal to 1, the equation becomes 2x square minus 2x is equal to 0, which is x square minus x is equal to 0, which is x inside bracket. So 2x square minus 2x is equal to 0. 2x common inside bracket, x minus 1 is equal to 0. 2 is not equal to 0. Therefore, x can be 0 or x can be 1, out of which x is equal to 0 is not the solution. And therefore, you end up getting only one solution, which is x is equal to 1. So, for a to be equal to 1, you have again only one real root, which is x is equal to 1. And similar will be the case when x is equal to minus 1. So if you substitute 2 into minus 1 raised to 2 minus 2 times minus 1 plus 1 minus a is equal to 0, because x, you need root of this quadratic equation to be equal to minus 1. So you substitute it and it should become 0. So for that, what value of a it becomes 0, we can easily find out. This is 2 plus 1 minus a is equal to 0. That makes it a is equal to 5. So if you put a is equal to 5, you will get two roots. One of them will be minus 1 and another real. Maybe you can find out that also. If a is equal to 5, you get 2x square minus 2x minus 4 is equal to 0. That makes it x square minus x minus 2 is equal to 0. So x plus 1 and x minus 2 is equal to 0. So x is equal to minus 1 is a root because delta is greater than 0, is a root, but it is not a root because initial condition says x cannot be equal to minus 1. Therefore, even if this is root by theory of quadratic equation, we have to scrap it, and therefore you end up getting only one root, which is x is equal to 2. So for a to be equal to 1 and for a to be equal to 5, you have you have one real root and one more is half. So 1, 5 and half is the correct answer. I hope you have now understood this solution, and see you sometime later. Thank you.